Here I have a Smokey the Bear balloon. When placed against a neutral surface like this wall, it falls to the ground. Yet, after being rubbed with rabbit fur, the balloon sticks to the wall. Here we have the fur and the balloon before they are rubbed together. Since each have an equal number of protons and electrons, they each have a neutral charge. But when the fur is rubbed against the balloon gains electrons from the fur because the fur is much higher up on the triboelectric series than the balloon is. Then, when the balloon, which has an overall negative charge now, is placed against the wall, the negative charge in the balloon repels the electrons in the wall, leaving behind a net positive charge in the wall, and since opposite charges attract, the balloon sticks to the wall. We can see the same effect take place here between this PVC rod and water stream. When the PVC rod is brought next to the water stream, nothing happens, as both have a neutral charge. But after the PVC rod is rubbed with fur and placed next to the water stream is attracted to it. Once again, the fur has donated electrons to the rod, giving it an overall negative charge. And then when the rod is brought next to the water stream, it induces the opposite charge, which attracts the stream to the rod. We can see the same effect take place here. When we place the charged PVC rod next to the table sugar, nothing happens. But when we place it next to the table salt, the salt is attracted to the rod. This is because the sugar, or the table sugar, is a covalent compound and effectively has no difference in charge between different sides of the molecule. However, the sodium chloride is an ionic compound. So the positive side of the compound is attracted to the negatively charged rod. Here we can see another example of the triboelectric series. When this wool is rubbed against this PVC rod, the PVC rod gains a net negative charge, and the can is affected by it. You can see the can move. But when I do the same with this glass rod and piece of silk, nothing happens to the can. This is because the glass rod and silk are too close to each other on the triboelectric series to create a net charge between one, while the PVC and the fur are on opposite ends. So the rod is able to gain a net charge which affects this can. When I bring a negatively charged PVC rod next to this electroscope, we can see that the leaves on the bottom move away from each other. This is because the negative charge on the PVC rod repels the electrons from the top of the electroscope to the bottom. This creates a buildup of negative charge on each of those two leaves at the bottom, and since like charges repel, the two leaves move away from one another. Now, when I remove the PVC rod and ground the electroscope, we can see that nothing happens. This is because no net charge was actually produced on the entire electroscope. It has the same amount of electrons now that it did before the negatively charged PVC rod was brought next to it. However, if I move the PVC rod close to the electroscope, ground it, and then unground it, remove the PVC rod, we can see that the leaves of the electroscope actually move away from each other. Then I bring the rod back, and they move towards each other. This is the opposite of what happened before. This is because when I moved the negatively charged PVC rod next to the electroscope, there was a buildup of negative charge at the bottom and buildup of positive charge at the top. When I touched it and grounded it, electrons from myself, the ground, moved into the electroscope, as the electrons from me were attracted to the positive charge at the top. Then, when I ungrounded myself and removed the rod, there is now an excess of electrons within the electroscope, so the leaves move away from each other as they are once again repelled. We can test if an object is positively or negatively charged by using the electroscope. If, as before, I create a permanent negative charge in the electroscope by grounding it, ungrounding it, and moving the PVC rod away, we can see that the leaves are farther apart as they were before, compared to what they were before, as there is now a net negative charge within the system. If I bring this slightly positively charged glass rod next to the electroscope, we can see that the leaves move slightly closer together. This is very faint as the glass rod is only slightly positively charged. But when I bring this negatively charged PVC rod back next to the electroscope, we can see that the leaves move farther apart again. So when I brought this negatively charged PVC rod next to the negatively charged electroscope, even more electrons migrated down to the leaves at the bottom, and so they moved farther apart. While when I moved the positively charged glass rod next to it, some of the electrons in the electroscope were attracted to the glass rod and moved away from the leaves. Since there was now less negative charge in the leaves, they moved slightly closer together. Here I am transferring electrons from this fur into the plate, inducing the plate with a net negative charge. When I bring this electrophorus on the top of the styrofoam block, the negative charge in the block is repelling the electrons in the plate as far away as possible. So when I tap it with this light bulb, electrons from the plate flow through the bulb and into me because I'm essentially ground. And now when I take the plate away from the block, the plate now has a net positive charge. So when I tap with the bulb again, the bulb once again lights. The electrons now flow through me as the ground into the bulb, into the plate. The plate is now neutral. But when I place it slightly above the block, tap with the bulb again, the bulb lights again. This is because the air between the plate and the block, there's a small enough distance where the air was actually able to conduct the charge between the two objects. So I tapped it with the bulb, same thing as the first time, electrons flowed from the plate into the bulb and into me. Now we can bring it away, tap it again, the bulb lights, and the plate is now neutral. But when I try it when the plate is this far above the block, nothing happens. This is because the distance between the plate and the block are too great for the air to conduct the flow of electrons between them. What's interesting is that we can continue with this process indefinitely. This is because all I am doing is transferring electrons each time. Because every single time I do this, one of the objects is still left with a net charge. Now, I'm going to induce a negative charge on this block again. Place the plate on top, and then ground it. You can hear the snap of the air, and that was just it grounding through me as the air conducted electricity. Then, when I bring this plate above the pieces of paper, the plate, which is now positively charged, is attracting the pieces of paper as it induces a small amount of negative charge on ends of the paper that are attracted to the plate.